okay? And we're going to be writing equations. Now, you guys have already practiced this. You've already wrote expressions in lesson 1-1, all right? So we're now going to write equations. What's the difference between an expression and an equation?
One has an equal sign.
Okay, raise your hand next time for me. But one has an equal sign and one does not. Which one has the equal sign? Okay, equation. So now what we're going to do is we're going to work on a lot of kind of the same concepts we were working on in the first chapter, but now we're going to apply it to equation work. Okay? So today, this should look pretty familiar to you. We're going to be translating sentences. Okay? The difference is now we're going to have an equal sign in there. So this today is a lot of review. Okay? This is going to be a lot of review for us. Now, there are 4 words or phrases that mean equal. Anybody come up with some things that mean equal other than the word equal? Okay?
Value or equivalent.
Equivalent. I like that. Equivalent. What else? Never mind. Okay. Okay, well, I've got a 2-letter word, and if anybody come up with it, I got a sucker for you. 2-letter word that means equal. Dalen. Is. Very good. All right, the word is means equal. Okay, that's going to be the big new word for this lesson. Okay, so on number 1 here, okay, is. Okay, is as much as. Is the same as. And then identical. And I do like the word equivalent because we know that equivalent also. So I'm going to go ahead and add a 5th one in there and do equivalent. We don't see it a lot of times in equation world, but it does mean the same thing. It means that both of them are equal. Okay? But is, I'm going to tell you right now, this is the big dog. Okay? Is means equal. Okay, so now when we go down to 1A here, it says translate each sentence into an equation. So 1A, 2 plus the quotient of a number in 8 is the same as 16. All right, does anybody have something that they want to try here? Ava, what do you got?
2 plus n over 8 equals 16.
Okay, let's take a look at what she's done here. I like the 2 plus. I mean, that's pretty self-explanatory. 2 plus. Now, you had to know what the word quotient meant, and she's saying it means division. Is that right? Mm-hmm. Ava's like, yes, it is. She already knows she's right, okay? So quotient means division, okay? We've got a number in 8. So you're dividing a number in 8. There's that is word, okay? That is word. That means equals. That's the big dog today, okay? Same as 16. All right, go ahead and take a second. I want you to do 1B on your own. 1B on your own. All right, Corlin, what did you get here on this one?
27k equals h to the 2nd power minus 9.
Okay, what do you guys think about Corlin's answer here?
That's right.
Correct. We got a lot of that's right and correct. She is correct, okay? So 27 times k, there's that is means equals. H squared, we should know that squared means an exponent of 2 by now, and then decreased by 9. Nice job. Very nice. Okay, does anybody have a question on those so far? All right, now one of the things that we're going to start working on, and we're going to talk about it today, we're not going to hit it very hard today, but we're going to start talking about it today. That way when we talk again on next Tuesday about this, it'll be a little bit easier because you already have some steps, okay? So what we're going to do is we're going to start looking at real-world problems, and we're going to have to look at what are the expectations for a real-world problem, okay? There are always going to be 4 steps on a real-world problem. You're going to define a variable, you're going to write an equation, you're going to solve it, get an answer, and then now you're going to start putting your answer in a complete sentence. This is going to be the expectation every time we have a real-world problem. Okay? So an example of a real-world problem, example 2 here. Read along with me. In 1919, Britain and France offered a flight that carried 2 passengers at a time. Now, there are more than 87,000 flights each day in the U.S., and how many days will it take for 261,000 flights to have occurred? Okay, so the first thing we're going to do is define a variable. What are we looking for here? What are we looking for here? Cole, what do you got?
How many days it takes to
Get those many flights?
yeah.
Yeah. So I don't hurt your head there. All right. How many days? That's what we're looking for. Okay. All right. So I'm going to put D for days. You can put whatever variable you want. It doesn't matter. Okay. So I'm going to put number of days. Okay. Now, when we're doing this, that first sentence is just extra information. Okay. In 1919, 2 people in a plane. Can you imagine that? 2 people in a little bitty plane, 1919. That sounds scary to me. All right? But now we have more than 87,000 flights each day just in the U.S. only. Okay? And then that'll take, how long will it take us to get to 261,000 flights? All right, so now we got to write an equation. Anybody got any ideas here? Okay, Cole?
261,000 divided by 87,000 equals D.
Nice job. Excellent job. Okay. Now, you may have, Court?
How do you know like which one they're talking about? Like it says how many flights or how many days it would take, but how do you know if they're talking about in the U.S. or in Britain?
That's a good question. We need to work on the wording of this, don't we? Okay. So in this case, we're only talking about U.S. Okay. All right. So now this is a great one. Now, if you would have said 87,000 times the number of days equals the 261,000, that would have been fine. I would have taken either one of these, okay? But right now, most of you would be thinking like this because that's what we worked on in the last chapter. Now, keep in mind, I don't know if we talked, I think we talked about it this summer a little bit. If you've got those zeros, remember you can cross those off, right? So when you've got a bunch of zeros like that, you can go ahead and cross them off, and basically you got 261 divided by 87. Anybody got an idea, a ballpark guess there, what they think that's going to be about?
3 days.
3 days. I'd have to probably agree there. So I'm going to take 87 times 3. Get 21, carry your 2. That looks pretty good. Okay? So we've got 3 equals D. Okay? So now, write a complete sentence. What does that mean? 3 what? What are we doing here?
Days.
Yeah. So it'll take 3 days. Let's say 3 days 4.
261,000 flights.
Very good. Okay, so this is our expectation out of you on a real world problem. Define a variable, write an equation and solve it, and then write a sentence explaining what does this mean, what's going on in our problem. Okay? Give you a second here to finish up your sentence. Okay, the next thing we see there is the word formula. What's the difference between an equation and a formula? Anybody got an idea there? Difference between equation and formula.
Like an equation, like the problem, like formula, like what you use to like get to the answer.
I need more than that.
It shows you how to solve that equation.
It shows you how to solve? Not quite. So what's the difference between this guy? So give me a formula. What's a formula you guys know? Throw one out.
2 pi r squared.
Okay. So 2 pi r squared is what? What does that equal?
C.
C? Well, it's close. How about just 2 pi r? He's converged circumference and area all into one. Okay? So 2 pi r. And then if I just say 12 equals equals 4x. What's the difference between these? This is an equation, right? And this is a formula. What's the difference? Ask Soccer if you can tell me. Okay, a formula, guys, is something that's been proven. It works every time on every circle in this case, right? So no matter the size of the circle, if I know what the radius is, I can come up with the answer every time, right? So it's a proven fact. Someone way smarter than me proved that this is going to be true every single time. An equation, it's not proof, it's just something we're solving. They've given us some random numbers and we're just going to solve it, okay? So that's the difference between a formula and an equation. All right, so let's write that out. Okay, so formula. It is an equation that states a rule for the relationship between certain quantities. Okay, so basically, guys, I mean, it's the big thing here. It states a rule. It's a proven rule. It'll work every single time. Okay? Okay, moving on here. We're going to do example 3 and example 4, and then we're going to be done. We're not going to worry about example 5 today. Okay, so we got 3 and 4. All right, so now that we know about a formula, we're going to translate these two formulas. So they're given to you in verbal, and you need to translate it into an equation. So I want you to take a second, and I want you to try 3A and 3B on your own. Okay? So it's just like the front side, but now we've got formulas. Let's see what you can come up with.